Okay, so let's find the kinetic energy of a rotating object. In this case, we have a solid disk rotating at 35 RPMs. The disk has a radius of 0.5 meters and a mass of 2 kilograms. As always, let us write down what we are given. The mass is going to be 2 kilograms. Radius is going to be 0.5 meters. And we have 35 RPM. And we're going to convert that to a frequency. And I told you in class that we can do that by dividing by 60. You can go look at your notes and see how the units cancel out. We're trying to keep things quick here. So that is going to give us a frequency. So let me say frequency is going to be equal to 35 RPMs divided by 60. That's going to be 0.58 hertz. Fine. And that's going to be important in a second. I'll show you why. So when we use our formula here, and the kinetic energy rotational is going to be equal to 1/2 I omega squared. And we don't have an angular velocity, and that's why the frequency is going to become important, because another formula that we're going to use is omega is equal to 2 pi f. So let's put everything in here together. By the way, when we find the moment of inertia of a solid disk, if you look at your chart, you will see it is 1/2 mr squared. All right, so let's put this whole thing together. We have kinetic energy is going to be equal to 1/2 times 1/2 the mass times the radius squared. There is the moment of inertia times the angular velocity, but we are going to replace that with 2 pi f. And make sure you square that. I have a tendency to not square that for some reason. I make the same mistake. You figure after 54 years I would figure that out. Let's see here, 1/2 times 1/2. Let's put in the mass times 2 kilograms times the radius, which is going to be 0.5 meters squared. So let me get that. You're going to square everything, the number and the unit. So let me put some of those in parentheses as well. Yeah, that makes sense. And then 2 pi, and the frequency we said was 0.58 hertz. And we're going to square that as well. Let me put all this in my calculator and get a number. And that's going to give me 1.68 joules. I'm using a Casio, and I can't find pi on here. I wish I had my Texas Instruments. All right, let's see here. Let's now take a look at an object that is rolling. All right, here we go. We have this guy here. And we have two things happening at the same time. It's sliding along, so let's add these up. So we're going to take the kinetic energy translational and add that to the kinetic energy rotational. Let's make a big old giant formula here. 1/2 the mass times the velocity squared, and then we're going to add that to the formula that we had before, where it's going to be 1/2 I times the angular velocity squared. But we're going to do some things here in order to make this work. We don't have an angular velocity again, but we do know that the angular velocity is going to be the velocity over the radius. Where does that come from? Well, if you look at the formula sheet from the College Board, I think that is on there, but I just solved it for omega, and I'm going to insert this value right here. So let's take a look. 1/2 times the velocity squared plus, and we know that I is going to be 1/2 the mass times the radius squared times, and this is where the fun part comes in right here. You're going to take the velocity divided by the radius, and remember that's squared, so that when we write it out, times, what I should have distributed that, Wm r squared times, watch this, what? Through the power of pre-algebra, these are going to cancel out. So we can rewrite our formula for, and this is only for a disk because this fraction right here changes depending on what is the shape of the object and how you calculate its moment. So don't use that formula for everything. The mass times the velocity squared. And I'm going to put in, I'll let you put in some numbers, and I'm going to put in some numbers, and through the power of calculation. All right, so I tried to speed things up here. So if we put in numbers for 1/2 mv squared, you'll get 9 joules. If you put in numbers for the rotational kinetic energy, you will get 4.5 joules. And if you add that all up, you get a total of 13.5 joules. So the thing you need to pay attention to is this fraction right here. If this was a hoop, it would just be 1/2 mr squared. And, you know, likewise, whatever you're going to use for a formula for the moment, you can change this fraction and then have your formula for total kinetic energy of a rolling object. There you go.